In this lecture, we will discuss about constructors and methods of ArrayList, and we will also discuss about how add method and remove method works in ArrayList internally. A constructor can be used to decide the state of an object during the creation of an object. ArrayList provides three constructors, such as in three ways we can initialize ArrayList during the creation of an ArrayList object. The first one is an empty constructor, which creates an empty list with an initial capacity of 10. The second form of constructor accepts a collection and creates a list containing the elements of the specified collection. Any subclass of collection interface can be passed as parameter, such as linked list, tree set, and so on. The third form of constructor can be used to create an array list with an initial size. This can be helpful if you know number of elements to be added in advance. This can improve the performance of the array list by avoiding copying of elements during array size expansion. Once the initial size is overflown, ArrayList automatically will enlarge its size. Now let's look at the methods provided by ArrayList. The first method is add, which adds an element at the end of the list. It returns a boolean value such as true or false. Returns true on successful insertion, otherwise false. Irrespective of the size of an array list, time taken to add an element is always constant. The next method is overload version of add method. This overloaded version accepts an index position where the element will be added. Adding an element at the specified location needs to shift one cell right to make way for newly added element. This method will slow down an application if frequently used on a large dataset. We will discuss how this method works internally at the end of this lecture. The next method is add all method. It has two overloaded versions. One is accepting a collection, while the second form accepts an index and the collection so that the elements of a collection can be added at the specified index. This add all method is very helpful to add a collection at the end of the list or at the specified position. The next method is clear method, which clears or removes all the elements of a list. The next method is clone, which is inherited from object class. It returns a shallow copy of ArrayList instance. This can be very useful because ArrayList is a group of object references, and any change directly change all the instances of ArrayList, but not the cloned instance. The next one is Condensed Method, which checks the existence of the specified element in the invoking ArrayList. It returns true if found, else false. The next one is Ensure Capacity method, which is used to increase the capacity of invoking ArrayList. The next method is Get, which returns the element at the specified position in the list. Any element at any position will return in constant time. The method isEmpty returns true if the list contains no elements, else false. The Iterator method returns an iterator object. This is useful to iterate over the list. The next methods are index of and last index of methods. Index of returns the index of the first occurrence of the specified element, and last index of returns the index of the last occurrence of the specified element in the list. Both of them return -1 if the list does not contain the specified element. The next one is list iterator, and it has one overloaded version which accepts an index position. List iterator is similar to iterator. The difference is list iterator has special methods which can work with ArrayList and linked list. List iterator is preferred when working with list. The next three methods are remove, remove all, and remove range method. Remove method removes an element from the list. Remove all method removes all elements from the list which are contained in the specified collection. Remove range removes data between a range. You can also sublist along with clear method to achieve the same effect as of remove range method. The next method is retain all, which retains only the elements in the list that are contained in the collection. It returns true if it could retain all, else false. The next method is set, which is used to update a list at the specified position with the specified element. one of the very useful method when working with ArrayList. The size method returns the number of elements in the list. It is quite useful in many situations. The sublist method returns a view of the portion of a list between the specified from index and to index -1. Using sublist with clear method replicates what remove range method does. Sublist is mainly used to get a portion of a list. The next method is trim to size, which trims the capacity of ArrayList instance to be the list current size. As we discussed earlier, the ArrayList instance may contain extra cells which are not occupied while expansion. These extra cells or unused cells at the end of the array will be trimmed down using this method. The next methods that are going to be discussed are very handy when list is working with arrays. The method toArray has two versions. One returns an object array, another returns array of same type as of passed array type as parameter. This version is very useful and commonly used compared to the former. We now discussed all the methods provided by ArrayList. It may be difficult for you to remember all these methods. But don't worry, Java have done their best to keep method names similar across different collections. Before going to show you the demo of these methods, I would like to show you how add and remove method works internally in ArrayList. An understanding on how these methods works internally is necessary when it comes to choosing between ArrayList and linked list for your application. Adding an element at the end of an ArrayList is really easy and this operation is very faster. But adding an element in between is a bit slower compared to adding at the end of ArrayList. As you know now, ArrayList stores data in contiguous memory blocks. Hence, there is no room for the new element to fit in. To make room, all the elements right to the specified position needs to be shifted up one cell. As you can see here, an element at index 2 is being added. The size of the array is 8 initially, indices from 0 to 7. Then to make room for the new element, all the elements from position 2 moves to one position right and empties index 2. Then the element 9 is added at index 2. Shifting of elements to make room for the new element is a costly process. At worst case, all the elements need to be shifted, such as an insertion at index 0 causes all the existing elements to be shifted up right. The remove method works opposite to add method. Instead of shifting up right, shifting to left to occupy removed element space. As you can see here, element 9 at position 2 is being removed. To occupy index 2, the element at index 3 needs to be shifted to index 2, index 4 to index 3, index 5 to index 4, and so on, thus occupying index 2. In ArrayList, the empty blocks are not allowed in between the elements. An understanding about these methods is very necessary. This is why ArrayList is not preferred if frequent addition or removals required in between the elements. If frequent modifications required between the elements, linked list is the best option to go with. We will discuss how linked list works in these situations. An array list is best when elements are added at the end and accessing elements using indexes such as using get method. Searching is also slower in array list, such as condensed method, index of method, and last index of methods. If array list is sorted, then binary search algorithm can be used to search a particular element faster. We will learn about binary search under collection algorithms chapter. We are concluding this lecture about ArrayList. Now it's time for a demo.